name is Wangare Kamau, part of the team here at FW Brands P.M E.A.T, and we are the facilitators of this webinar. So as some of you may be aware, we have done several of these webinars with Husky Technologies. Yet again for another insightful discussion. Today, the focus is on sustainability in beverage packaging, and joining us is Michael White, the Director of Business Development for Closures at Husky Technologies. He will take us through the innovative approach that Husky Technologies has for us in ensuring that we use all PET for closures and bottling. And because I know you didn't sign up to listen to me, I will invite Michael to the stage now. The stage is yours.
Thank you for that warm welcome, and thank you, the audience, for the privilege of your time. Good morning, good afternoon, good evening from wherever you may be joining. And again, thanks for your time. I'm going to walk through an exciting technology that we've developed here at Husky, and let's dive right in. I'm going to basically talk today about three key areas and structured the presentation accordingly with our new PET closure development. One, I want to really focus on the benefits around enhanced consumer security that this technology provides, the improved capping performance that is also inherent with the design, and also stress that it is fully compatible with industry standard neck finishes that are available today specifically in the still water market. So if we look at the current state today, we have typically a HDPE cap on top of a PET bottle. While the HDPE closure is recyclable, it's typically downcycled into non-food contact applications, whether it's lawn furniture, pails, different containers for non-food contact applications, in this case, motor oil. Really, the holy grail or the vision of Husky, which is now a reality, is a all PET package, meaning both closure and bottle, that really supports that whole circularity and that circular loop of the circular economy, where you can manufacture, consume, and recycle both the closure and the bottle, and reuse, and keeping that material within the circular loop, and not having, in the case of HDPE, going out of that circular loop and having to inject fresh new virgin material. So when we started down this path of the PET closure development, there were a number of non-negotiable design requirements, and really we focused on 4 key areas. One being the safety and experience, the performance, weight, and then design of the closure itself. So from a safety and consumer experience perspective, we really wanted to ensure that we had the industry's most secure approach to tamper evidency. We wanted to ensure that there was no negative drawbacks to the intuitiveness, especially in tethered. We wanted to make sure that we were compliant with tethered regulations, specifically the EU directive that was passed back in 2019 and became legislated in July of 2024. On the performance side, we wanted to ensure that there was no compromise in terms of capping performance versus the incumbent material, which is HDPE. No compromise on the performance in terms of the closure performance and how it performs in terms of sealing, impact resistance, application torque, removal torque. So those are all things that lend themselves to how the consumer experiences the brand, and it basically has a domino effect on the consumer's perception of the brand itself. So we wanted to make sure that there was no compromises on that front. From a weight perspective, there is a difference when you compare PET to HDPE in terms of mass density. So we wanted to make sure that we were as close as possible to HDPE in terms of weight, because PET has a higher mass density than HDPE. So there is some tricks that we say, or innovative design approaches, let's say, that I will talk about in the subsequent slides on how we were able to closer approximate the weight performance on a like-for-like closure relative to HDPE. And this approach really shows that there is a lot of runway in terms of lightweighting ahead of us as well. And then finally, on the design aspect, we wanted to make sure that we were fully compatible with industry standard neck finishes. Again, I want to highlight that we are focused today on still water, but then with a roadmap looking towards more challenging applications in the aseptic and eventually in light carbonation spaces. And then really how the injection molding approach that we are using really provides a more unconstrained approach to design. And I'll get into that a bit more in the subsequent slides. So if we look at a typical closure today, there's really three key aspects to the closure. You have your shell, you have your bridges, which are the little connectors between the shell and the tamper band. And they're also not only are used to help fill the tamper band, but they perform a function in terms of security and showing that when you actually open the closure, they actually fracture, which then leads to a visual tamper evidence. You can see that when the bridges are broke, the product has been previously opened. So if it's sitting on a store shelf and waiting to be purchased, this is probably something that you would avoid. You would look for bridges that aren't broken. And really, when we look at the TE, the tamper evidency performance, there are a number of stakeholders in this whole security aspect. Obviously, we have the consumer by the fact that you want to make sure that the product that you're purchasing is secure and hasn't been tampered with in any way. From the brand perspective, you want to ensure that you're delivering secure packages to the consumer. From the closure producer perspective, you want to make sure that the closures that you're delivering to the brand are secure as well, and that they have a tamper evidency function that performs as intended. And then finally, from the retailer perspective, there is some equity in this aspect as well, because you want to make sure that the products that you're selling from the brands are secure as well, so that everybody's assured of a common security that the package that is being purchased has not been opened previously. So if we go back a bit in time, I wanted to highlight an example where the risks are quite high when there is a package that is compromised on the store shelf. Now, back in the early 80s, there was an issue that Johnson & Johnson experienced in Chicago with some cyanide poisoning, where there was bad actors that were going onto the store shelf and opening the packages and inserting cyanide pills with some malicious intent. So if we look at that from the consumer perspective, obviously the consumer has a health stake in this whole sequence. And then the brand, retailer, and closure producer, not only to preserve the health of their potential consumers, but they have a financial risk as well at stake in ensuring that the package is actually secured. And this whole event really was the impetus for improving security on packages, whether it's food, pharmaceutical, or even beverage. And that's what kind of leads us today, what the current state that we have, where we've all been conditioned when we go to open a bottle for the first time, that you actually feel from a tactile perspective, an audible perspective, that you actually hear the bridges break, and you actually can see that the bridges have broken, and thus thereby ensuring a level of consumer security. So again, unfortunately, there are bad actors out there that are even tampering with packages today. And this was a quick few slides that I did through some Google searching to see that there's still not only from a security perspective, but also an anti-counterfeiting or a counterfeiting perspective as well. By having a good secure package, you're able to ensure that counterfeiting is virtually eliminated, and you're for sure able to ensure the security of the beverage product so that it is pure when it is delivered to the customer for the first time. Now, when we I want to give you a bit of an insight into our design approach and some of the challenges that we faced with the developing the PET closure. So talked about the function of the bridges. What we have here is a series of X-rays in this section here that are stages as the closure is being applied to the neck finish for the first time. So one of the approaches that we employ is the incorporation of this cam that's on the tamper band of the closure. So as the cam makes contact with the pilfer proof, which is this feature here on the neck finish, it begins to stretch the band, and the bridges are stretched and deform around the pilfer proof until it is in this position here. So this cam only allows one-way passage. When you go to unscrew the bottle or unscrew the cap, from the bottle for the first time, this feature here on the top of the cam makes contact with the bottom of the pilfer proof and prevents the band from proceeding further. So what that does is, as the shell is removed and continues to be unscrewed, the bridges begin to stretch, at which point they ultimately fail and fracture. So while HDPE can accommodate this because it has a higher level of elasticity than PET, when we tried this with PET, we ended up with bridge failure during the application. So we didn't even get to the point where we could stretch the bridges from an opening. When we were applying them, they were already starting to fracture because they can absorb a certain amount of elasticity, but at some point they end up fracturing. So this was our first contradiction. And really with any beverage closure today, there's always this compromise between good tamper evidency and good capping performance. And there is a trade-off that you have to design for. And what do I mean by that? So from the capping perspective, if you look here, I have drawn in an exaggerated cam design, here in yellow dash, which indicates a much shallower cam. So when you go to apply, there's virtually little stress that is placed on the bridges. So while you may get a good capping performance, what you find then on the removal is the band may come off with the closure itself. So not enough interference, you would end up then with hinge bands. On the flip side, if you want to have maximum interference for good, ensure that all of the bridges are broke, when you have too much interference, and here again, I've exaggerated the depth of the cam itself. When you go to apply the closure for the first time on the capping line, you'll end up with broken bridges. So there's always this trade-off that you want to find the right balance of cam protrusion. And this is the same with a folded band approach as well, because with a folded band, you still have that certain amount of interference as you're being or as you're applying the closure to the bottle itself. So there's a trade-off that you need to respect. And really then the challenge becomes, well, how can we get a good tamper evidence without any kind of existing capping window? And the development that we came up with is shown here. So what we did is we actually got rid of the cam itself. So there is no stress as the bridge or as the closure is being applied. And then what we did is hit the tamper band with a high energy source to actually shrink the band around the pilfer proof, so that it solves both of the challenges. You get a good capping performance and an excellent tamper evidency. So that animation really shows the concept that we developed. Here it is in real time on the right. You'll see all of this happens over a span of 1.2 to 1.6 seconds. So as the bottle is rotated, we hit it with that energy source, which actually shrinks the band around the pilfer proof. And we demonstrated this concept at the NPE show in Orlando in 2024. That is the concept that is shown here in the top left. And we actually were forming these bottles live on demand and then distributing them to show attendees to have them really get a sense of how this interacts and the experience the tamper evidency for themselves. And I'll get into that a bit later. Now, this design here that I'm showing, our prototype, was capable of 15,000, so 15,000 bottles per hour. We know that that's nowhere near the level of industrialization that is needed to support the wide majority of beverage brands or applications in the market today. So what we showed at Drink Tech last fall was our scaled solution, our HyCAP SecuRE platform. And here's a video here that will describe how it is. So if you picture this device that's shown here, the HyCAP SecuRE, on the filling line immediately after capping, the bottles are capped as normal. They're passed through on the filling line into this device where the star wheel picks them up. They're then passed on to the carousel. So there's a timing screw that adequately spaces them. And then this capping chuck or stability chuck, if you will, that provides a certain amount of top load on the spring base, which then ensures that we hit the tamper band at the exact same height every time. So there is a level of consistency. Once they pass through the heating zone, they're then passed out the other side, which goes through a vision inspection that ensures that the tamper band has been properly formed, and that there are no cock caps, that the application of the cap has been applied adequately, and a number of other different features, whether there's broken bridges, how does the closure look from a quality perspective. So there's a bunch of different variables that we can set that the cameras can then inspect for and then immediately reject off the line if needed. So if we look at typical capping defects, they really can come down to two areas, the shell-related and the band-related. So on the shell-related side, you can look at high caps, so inadequate torque, it's not fully seated, which ends up with potential leakage. Again, our vision inspection would pick all of these defects up. You could have a cocked or tilted cap, which would mean that the closure was improperly applied. Again, getting that proper trade-off between tamper evidency and capping application. And that's really trying to find that correct balance. Again, if we look at it from the new PET closure perspective that Husky is promoting, basically all of the band-related issues are eliminated because there's no stress on the bridges as you are applying the closure to the bottle. Any kind of tuck unders are non-existent because there is no stress on the band and the bridges as the closure is applied to the bottle. There is no interference fit. It is basically a sleeve fit, so it's just passing over and then formed and ensuring you get 360 degrees of coverage every time, all the time. So if we look at typical capping curves here, if we look at, application torque curves, with a typical HDPE closure where you have either an interference band with a integrated cam or a folded band, there's really two peaks. So as the closure begins to be applied to the bottle, the application torque starts to rise till it gets to a certain point. This is the maximum here where there's maximum torque required as the cam makes maximum contact with the pilfer proof on the neck finish. It then, once the band passes over the pilfer proof, the application torque drops, where it then begins to rise again until eventually the top panel of the closure hits the top sealing surface of the bottleneck. So there's 2 points here if we look at a typical application torque curve for an interference or a folded tamper evident band. So 2 points of stress on the closure itself. This one meaning especially on the band. Now, if we look at the formed tamper evident band approach, it's a much gentler approach in terms of application torque. And really, you only are using that secondary peak, and that's where then finally the top panel hits the top sealing surface on the bottleneck. So again, much gentler capping torque applied to the closure itself. Now you may ask, okay, why injection molding? One of the keys is the design freedom and how you can incorporate much more complex geometry. The example shown here is a typical our 2925 tethered design in PET. And you can see the geometry here. So all of that is formed in mold with our slides here, shown on the slide pairs here where my mouse is. So every cycle, those slides are moving back and forth around the core. The part is injected, and all of this intricate geometry is then formed in the slides itself. The other benefit is the scalable and precision aspects of injection molding. Here shown our HyCAP platform, capable of we have 4 different tonnage variations: 225, 300, 400, 500, and you would select the appropriate one based on the cavitation that your application requires, which can handle between 24 and 96 cavities in this case. And one of the key aspects here is our control system that we've developed, where we're looking at the ability every 500 microseconds, so 2,000 times per second, we're scanning the position of our screw so we know exactly where it is and can ensure that we're metering the proper amount of material into the cavity. And then by having the ability to overlap processes and continually pack out the part, we can really adjust for shrinkage and ensure a consistent part-to-part, shot-to-shot level of quality that's unmatched in the industry. So if we look at the applications that we're going to market with, again, we're at the very beginnings of this journey, at the early stages. We're focusing on still water. The first neck finish that we're targeting is the GME 3026. You may know it by its more common name, the 2925. The T represents the tall. So this is slightly taller than the standard 11.2 height, a millimeter height, 2925, to give it a little more grip zone. But if we look at the cycle time, relative to HDPE, it is a little higher in terms of percentage. We're talking around 15% longer cycle relative to HDPE. That's simply because of the mass density of the product or of the material, and also requires additional cooling time. If we look at the part weight, little higher at approximately 40% relative or vis-a-vis the HDPE equivalent. And I'm going to get into a bit more discussion on how we're able to bring that closer to weight neutrality in the next few slides. But again, this is the go-to-market application, both a tethered and non-tethered design for 2925. The tethered design meets all of the requirements of the EU directive, primarily 25 Newton pull force and 15 openings and closings. We also have two other designs we're at the touch and feel stage for both the 2622 3-start for water applications and the 3-start GME 3025 38 millimeter for larger format water applications. Now, at Husky, we have a mantra that we're always continually looking at how can we eliminate waste. And as it applies to closure design, we are looking at specifically, and is shown in this top image here in blue with these little dashed rectangles, we look at all of the different features on a typical closure. And this is a iterative process, a dynamic process that is essentially never ending. We have a portfolio of closures, made it to industry standard neck finishes, and we are continually challenging ourselves on where can we take out weight out of this closure without compromising usability or performance. So in the case of this design here, we're looking at things like the top panel, the bridges, the cams, the threads, the plug seal, the outer seal, all of those different features. And we say, where can we take out, 100th, even maybe as aggressive as a 10th of a gram in certain aspects of the design without compromising the performance or the consumer experience. And we leverage a number of FEAs, both mechanical and flow, to achieve that. And this process is applied to every design, whether it is for a standard neck finish or if these are for entirely custom designs. And so we continually challenge ourselves on that. And an example now where we look at how can we get closer to the HDPE weight without compromising performance or usability. Now, the rigidity of the PET material really unlocks some benefits that we can leverage to our advantage in terms of lightweighting. So if we look at a typical HDPE / PET dispensing system that exists today, so this is a 2925, you have 3 starts with a 180-degree thread length for all of them, so all 3, which is shown up here in red. Then we have our closure down here. We're using our HDPE 1.15 standard height closure with the weight of the neck finish at 2.42 grams and 1.15 for the cap. So we're ending up with a dispensing system weight just under 3.6 grams. Now, I mentioned about the rigidity of the material itself and how that can unlock lightweighting opportunities. Well, if we look at the 180 degrees, we really don't need those extra 50 degrees of thread engagement to achieve the same level of performance that's required. So if you have a standard 2925 neck finish, it's about 12.6 millimeters in terms of height. So that's from the top sealing surface of the thread, or of the finish, down to the bottom of the support ledge. So 12.6. That area in green is all waste when we look at an application for a PET cap, because you simply don't need that extra level of thread engagement. So you're actually able, if you go down to 130 degrees, and that was all proven through our simulations and then verified in the lab through our dispensing system testing, the closure testing and validation, we're able to actually take 3 millimeters out of the height of the dispensing system, or sorry, the neck finish, and consequently out of the closure itself. So we can actually end up with a dispensing system weight at 2.9 grams with a neck finish at 1.7 grams and a cap weight of around 1.2. So we're getting closer in terms of approximation in weight to the incumbent, and a lighter neck finish as well. So taking weight out, not compromising performance or usability, and ending up with an all material or all PET material dispensing system at a lower weight. And what does that represent? Almost 20% at the dispensing system level. That's comparing the 3.57 to the 2.9 grams. Now, one of the other benefits of PET comes around with the approach that Husky's using with our forming of post-mold forming of the band itself, is there is no question about tamper evidency in the level of security that it provides. So it's very clear that when you go to open the closure, that there's an audible sound as the bridges break. There is very clear tactile response, so you're feeling it as those bridges are breaking. And then there's a very visual cue that the fractured bridges, or that the bridges have fractured. So I have an example here. It's a 2925 tethered, and hopefully the mic picked that up. But it was very clear that the bridges have broke. I definitely heard it and saw it with my own eyes and felt it as I was opening the package. So you can see here, this is the example that I showed on the right on the few slides prior. 2925 tethered, meeting all of the EU requirements. So similar to HDPE, as PET resin manufacturers introduce new grades, we're always evaluating new grades because brands may have certain alignments with certain suppliers. Maybe PET resin suppliers are not global in footprint. They may be more regional. So we are continually looking to evaluate different resins. Today, as it stands, we began this journey working with Alpec and their Capital resin. And we find that that gives a very good injectability, ejectability, and passes all of the performance requirements of the major brands for still water. So that material type is available now for market for those 2925. We're also looking at different rPET grades and additional grades from some of the other more regional players, as shown on the map here. One other aspect I want to highlight is the recycling associations. So you may be familiar with APR or Recyclass or EPVP. We have submitted our designs and formed working groups with members of those associations, and have now achieved like design preferred status with all of those recycling organizations with our specific PET closure using the Capital material. So full compatibility with EPBP, Recyclass, and also APR. This is just an example I went through as the previous slide, but looking at the 38 millimeter, again, identifying areas of waste and being able to show that there's an opportunity to additionally lightweight the dispensing system to end up with a dispensing system weight that is less than the incumbent today. This one here is showing 38 millimeter. The standard three-start GME 3025 neck finish for still water application. Again, I mentioned earlier, meeting brand requirements. So again, the tamper evidency approach that we're employing or pursuing is really unmatched when we look at the current state. I think we're all familiar with, probably have experienced this at least once in our lifetime, say purchasing a commodity type 500 ml water, gone to open it, and say that trade-off between that I was experiencing or explaining before on tamper evidency and capping maybe wasn't dialed in properly, and the bridges all didn't break, or the tamper band came off with the bottle, and then you're left wondering, should I be really drinking this? With our approach, that question is entirely eliminated. We passed bottle drop performance, base horizontal at 1.4 meter height, SST sealing, pass again, no leaks or blow-offs. Application torque within required requirements for the brand. In the example of the 2925, we're within 12 to 17 inch-pounds. Again, we're continually looking, in addition to that elimination of waste that I spoke of earlier, we're also looking at how can we leverage design to enhance our application torque performance. And things like, reducing the contact surface between the threads on the closure and the neck finish itself. How do we use design versus additives, if you will, into the application to ensure that we're meeting the application requirements or torque requirements, in this case, of the brands. Again, removal torques, here's where we can look at things like adjusting the amount of preload with the plug seal on the design itself, reducing different contact surfaces, and if needed, incorporating different additives into the mix to help with the removal torque performance. Again, I spoke at length about the capping performance and how our innovative approach minimizes stress on the bridges. That's another example. And then full compliance with the SUP directive. Also, when you look at new legislation beyond tethering, which is now being or has been implemented into the EU in terms of the plastic package waste reduction initiative with the PPWR, requiring 30% of the beverage package to have 30% of PCR by 2030, upping to 65% by 2040. Again, this is where a monomaterial package makes total sense, in incorporating additional percentages of recycled content. If we look at the manufacturing matrix for our solution, we can leverage our existing machine. On the tooling side, there is the requirement for a new cold half, simply because you're dealing with different shrinkage performance or shrinkage characteristics of PET, comparing PET to HDPE. On the resin dryer or the TE former, those are new technologies that obviously are required for processing PET and for processing or producing a PET closure that exhibits that forming approach. This is all backed up and supported by our proactive monitoring, our Advantage Plus Elite package and platform that is incorporated and shipped with every system. So if we look at the value proposition just quickly, We really think that our novel tamper evidency approach really provides an unmatched level of security that is unmatched in the industry today. You know, being able to incorporate higher levels of rPET into the package really satisfies those future requirements by the PPR or PPWR legislation, and then additional value drivers on the stress-free application, so improving capping performance, having more design freedom with complex geometries with the injection molding process. Explained at length the lightweighting opportunities that the rigidity of the PET material provides, fully compatible with standard neck finishes. Since we are doing no post-mold modifications to the closure, i.e. a scoring of the closure itself, it's really a more dust-free manufacturing approach. And you also get the side benefit of improved barrier performance relative to HDPE. Really, in conclusion, I want to thank you for your time and really wanted to emphasize that our Secure Plus technology really provides enhanced consumer security over and above what is available in the market today, improved capping performance, and our designs are and will be in the future fully compatible with all industry standard neck finishes. So with that, I want to thank you for your time, and I look forward to speaking to you. If you have any questions that you'd like to explore further, my contact info is there, my mobile and email address. Feel free to reach out with any questions that you may have, and I will be sure to respond back. So again, thank you very much for your time.
Okay. Thank you very much, Michael, for that insightful presentation. And now we have some questions that have been submitted in our chat session during the webinar. And because of time, I'm only going to get to some of them. And if we don't get to your question, the Husky team is going to reach out to you with a response from Michael.
Yeah, so sorry, I have, just reach out with any questions that we don't get to via my email.
Okay. So one of the questions that I am going to have our speaker answer during this session is, can PET closures be recycled with bottles without separation?
Yes, good question. As it exists today, typically how the bottles are and the closures are recycled is like a float sink method, where the package will be ground up, and then the PET, because of the density of the material, sinks, and the HDPE floats. So then it's quite easy to separate. With an all PET package using materials like Alpex Capital. This is bottle grade material. So simply it's a lot easier because you don't need to employ that float sink method. You can simply grind it up and then reprocess it if it's in plant, or look to sell out to reclaimers that will repurpose it for packaging applications.
Okay, thank you very much. Another question I'm going to ask is, since PET is denser than HDPE, how does it still enable lightweighting?
Yeah, that was a slide I spoke. I had two examples there where we really look at eliminating waste out of the application. So the application in this sense being the closure. So what we would do is apply our systematic simulation tools to the design itself. In this case, maybe we look at the incumbent closure, the HDPE, as a starting point, and say, where can we remove weight out of the application, and then apply those learnings to the PET design. And with the understanding that the material properties and behaviors are quite different, that the rigidity of the PET material offers you a bit more opportunity to lightweight at a dispensing system level. So looking at it from a more holistic approach to save material not only on the closure, but also on the preform.
Thank you. I think I'm just going to ask one more, and then you can get to the rest via email.
Sure.
So how does this approach also ensure consumer safety? You had spoken a bit on this, but maybe you can reiterate.
Yeah. The existing approach today uses either a folded-in band at the bottom or a integrated cam. And as the closure is applied to the neck finish, that cam or the folded band is prevented from the tamper band from passing back up off the neck by the pilfer-proof feature on the neck finish. So with our approach, what we've done is we've eliminated the cam itself so that there is no stress on the bridges, which are the little feature that connects the shell to the band. So we've eliminated that. And the band itself is then, since there's no stress during the capping process, we're assured of very good capping performance, no broken bridges during capping. And then when we look at removal, when we have that band kind of formed around the pilfer proof, we're ensured that the security level of this approach is unmatched because we get 360 degrees coverage with no stress on the bridges until first opening. So that's really the approach that we're taking. And then the breaking of the bridges, it's a very audible approach, audible experience, if you will. When you go to open it for the first time, you definitely have a tactile response in your fingers as you're opening. You hear it and you can see it.
Yeah, thank you for reiterating that, because at the end of the day, the safety of the consumer is paramount, and
Exactly.
these approaches, everybody, all the stakeholders get to do what they need to do with this approach. So thank you very much for this session. Thank you for everybody who attended this, and for those who are going to be watching this after the live session, we also thank you for doing so. And now I am going to ask Michael to bid us farewell.
Thank you for your time, everyone, and have a good day.